Hi, this is Jasmine from Tutors 11 Plus. Today we'll be looking at a video on HCF and LCM. This follows the previous video we had on prime factors and factor trees. So we'll be using them to work out how to calculate the highest common factor and the lowest common multiple. HCF and LCM using prime factors and factor trees. We often need to find the highest common factor, the HCF, and/or the lowest common multiple of a pair of numbers. Let's remind ourselves quickly what are factors or multiples. A factor is a number which divides exactly into another number without leaving any remainders. And a multiple is a number which is in its times table. Let's have a look at an example. Let's look at the highest common factors of 12 and 18. So let's first list out the factors. So the factors of 12 are 1, 2, 3, 4, 6 and 12. And for 18 they are 1, 2, 3, 6, 9 and 18. Now these are all the factors for 12 and 18. What we can then do is look at which of these factors are in common between the two. We can see that 1 is common, 2 is common, 3 is common, and so is 6. Now, of the common factors, which one of these is the highest? So, the highest common factor, or the HCF, for 12 and 18 is 6. That means that 6 is the highest number that divides into 12 and 18. Now let's look at a lowest common multiple. So if we wanted to look at lowest common multiple of, for example, 4 and 6, first thing we would do is write out the multiples. So multiples of 4, 4, 8, 12, 16, 20, 24, etc. And for 6 will be 6, 12, 18, 24, 30, 36, and we can go on. Now, of these multiples, which of them are common multiples? So we can see here that the first common multiple is 12. And then we have another one down here, which is 24. And there's likely to be many more. However, what we are interested in is what is the lowest common multiple, or the LCM. And we can see here that the lowest common multiple of 4 and 6 is 12. So there are a number of different methods that we can use to work out the HCF and the LCM. Method 1 is what I've just shown you, where you write out all the factors and multiples and then you compare lists. However, it's very easy to make a mistake here, especially when you have larger numbers. So what else can we do? We could use method 2, which is using prime factors and factor trees. This is a much more efficient method. For a reminder on prime factors and factor trees, please look at my earlier video. Okay, using prime factors to find the HCF and the LCM. Now remember, a prime factor is a factor which is also a prime number. So prime factors of larger numbers can be compared and used to calculate HCFs and LCMs. So let's look at an example. Find the HCF and the LCM of 24 and 180. The first step is to find the HCF. So we write 24 and 180 as the product of their prime factors. (24) and 180. I'm now going to do factor trees. So 24 can be broken out into 4 times by 6. 4 can be further broken out into 2 times 2. 2 is a prime number, so I will circle that. 6 is broken out further into 2 times 3. These are both prime numbers, so my branches of the tree stop there. For 180, this can be broken out into 18 and 10. 18 can be broken out further into 2 and 9. 2 is a prime number, so I will circle that there and the branch stops. 9 can go further to 3 times 3. 3 is a prime number, so that stops there. 10 can be broken out into 2 and 5, both of which are prime numbers, and it stops there. Now what we said was writing 24 and 180 as a product of their prime factors. So what we do is we write 24 is equal to 2 times 2 times 2 times 3. And 180 is equal to 2 times 2 times 3 times 3 times 5. Now I've written them in order. Remember, when we were looking at factor trees, it's always best to write them in order and to keep your working neat. So to recap, we write 24 and 180 as a product of their prime factors using factor trees. And we then write the product of prime factors for 24 is 2 times 2 times 2 times 3, and the product of prime factors for 180 is 2 times 2 times 3 times 3 times 5. Step 2. To find the HCF, we find any prime factors that are in common between the products and we multiply them together. How do we do that? Any factors that are in common between the two. So there's a 2 and there's a 2. So there's 1. Here's another number that's in common, another pair of 2's. There's no more 2's in common, but the next one is a 3, and we have a 3 here, and that's it. So these are factors that are in common between 24 and 180. And what we then need to do is multiply them together. So what we do, 2 times by 2 times by 3, which is 12. So the highest common factor for 24 and 180 is 12. To recap, the highest common factor is 2 times 2 times 3, which is 12. And what we did is we found the prime factors that were in common between the two products and multiplied them together. Now we found the HCF, we move on to the next part, step 3, which is looking at the LCM. So we then need to cross off any numbers used so far from the products in order to identify any that have not been used. Let's do that together. So let's cross off these as they have already been used. and we are left with this 2, this 3 and this 5. So these are the 3 products that have not been used. Yep, 2, 3 and 5. They're the remaining products that have not yet been used. We move on to step 4. So to find the LCM, we multiply the HCF by all the remaining numbers from the products that have not been used. That's what we identified in the previous step. So we multiply the HCF by all the remaining numbers. So now we want to find the LCM, which is equal to the HCF, which is 12, and the remaining products which haven't been used, 2 times 3 times 5, which is equal to 360. So the lowest common multiple of 24 and 180 is 360. We work that out by multiplying the HCF by the products that have not been used. To recap, the LCM, the lowest common multiple of 24 and 180, is 12 times 2 times 3 times 5, which is 360. And that concludes the video on how to calculate the highest common factor and the lowest common multiple of a pair of numbers using prime factors and factor trees. You can see that there are a number of steps to this and it can get quite complicated. So, as we always say, you should keep practicing because the more you practice, the better you'll get. Thank you.